Welcome to a new section. Today we are going to study about laws of refraction of light and refractive index. Laws of refraction of light. For that, let us revise refraction of light. We know when a light travels from a transparent medium to another, the direction of light changes. That is, when a ray is incident like this, after refraction, the direction of light changes. This phenomenon we called it as refraction. Let us draw a normal to the point of incidence. Let us mark these rays, that is, this is incident ray and this is refracted ray. This is normal, we mark it as N dash. This angle is I and this is R. First law is that the incident ray, refracted ray and the normal to the interface of two transparent media at the point of incidence all lie in the same plane. So this is the first law, that is, this incident ray, the refracted ray and the normal all lie in the same plane. The second law is that the ratio of the sine of the angle of incidence to the sine of the angle of refraction is a constant. For the light of a given color and for the given pair of media, that is, sine of the angle of incidence, that is I, divided by sine of the angle of refraction, that is R, is a constant. This law is also called Snell's law of refraction. This constant, we can call it as N21, is the refractive index of the second medium with respect to the first medium. So these are the two laws of refraction, that is, the incident ray, the refracted ray and the normal to the interface of two transparent media at the point of incidence all lie in the same plane. Second, that is Snell's law of refraction, that is sin I by sin R is equal to a constant. We call it is the refractive index of the second medium with respect to the first medium, where I and R are the angle of incidence and the angle of refraction. Now we are going to study the refractive index. Refractive index. Let us draw the case of refraction. Now let us understand what is refractive index. refractive index is a dimensionless number which can be linked to the relative speed of propagation of light in different media. That is, the light propagates with different speeds in different media. And this refractive index describes how fast light travels through the material. So its value for a given pair of media is the ratio of speed of light in one medium to that in another medium. To understand it, let us consider the light travels at a speed of v1 through medium 1 and with a speed of v2 in medium 2. Then the refractive index of medium 2 with respect to medium 1, we normally represent it as n21, which is equal to speed of light in medium 1 divided by speed of light in medium 2, that is v1 divided by v2. So we got the equation for the refractive index n21, that is a refractive index of medium 2 with respect to medium 1. In the similar way, we can write n12 is equal to v2 by v1. That is, refractive index of medium 1 with respect to medium 2 is speed of light in medium 2 divided by speed of light in medium 1. Now we know speed of light in vacuum is taken as 3 into 10 raised to 8 meter per second. And we also know that light travels the fastest in vacuum. In air, the speed of light is marginally less compared to that in vacuum. But in other mediums like glass or water, speed reduces considerably. Let us consider a special case here, that is medium 1 is vacuum or air. Then we can take the speed of light, that is v1, as c, the speed of light in vacuum. Then refractive index of medium 2 with respect to vacuum is considered, and we represent it as n2, and we know it is speed of light in vacuum divided by speed of light in medium 2, and that is equal to c by v2. And this refractive index we call it has the absolute refractive index. So if we denote the absolute refractive index as Nm for a medium, and that is equal to C divided by V, where C is the speed of light in vacuum and V is the speed of light in that medium. So the absolute refractive index Nm is equal to C divided by V. And this absolute refractive index of that medium is called its refractive index. So we studied refractive index of a medium. Before concluding, let us understand one more term, that is optical density. Optical density is the ability of a medium to refract light. So it is not the same as the mass density. Here the optical density is the ability of a medium to refract light. So if you are comparing two mediums, a medium with a larger refractive index is optically more denser than the other. So the other medium with a lower refractive index is optically rarer medium. So we are saying the refractive index is more, then that medium is optically more denser than the other medium. So in optically denser medium, the speed of light is less than optically rarer medium. So we can say, if a ray of light traveling from a rarer medium to denser medium, the speed of light decreases or slows down and it bends towards the normal. And if the ray of light travels from denser medium to rarer medium, the speed of light increases or speeds up and bends away from the normal. Thank you for watching this video. Keep learning. If you are not yet subscribed to our channel, please subscribe it. Also, please like and share this video.